welcome to the session. In today's session, I will present to you the overview of the database system technology. But before we go to that, what are the issues which we have considered for today's session? Well, in today's session, I will be first introducing you to the basic benefits of database technology. Then we will be moving on with the basic functions of database technology, and then gradually we will move on to the more theoretical concepts such as transactions, referential integrity, normalizations, and towards recovery, and towards the end we will cover up some basic issues related to concurrency. But to begin with, what is a database and what is database management systems? Well, the definition of a database management system boils down to one of the major issues or one of the major terms which we call persistence of data. That is, persistence, that means data values stays with database till explicit request to remove them is made to database. And a database is a collection of persistent data of an enterprise for an application system. Now, two terms which are very clearly coming out of this particular definition, that whenever we are talking about the database system, we are talking in terms of persistence of data, that is, the data has to stay. And second thing what we are talking about is we are talking about data of an enterprise, that is logically related data. It may be enterprise resource planning application or whatever. There has to be some logical configuration of data for an enterprise, and database management system actually has to manage the whole data for it. But what is the major feature of any database management system? Well, the additional feature which we call in any database management system that should exist is centralized control of an enterprise, data of an enterprise. What do we mean by centralized control? Well, a database management system gives you an opportunity as a package. You are interacting with it for anything or for any amount of data or for any amount of information which you want to get from about any organization. And that's a centralized control. Somebody is controlling the data delivery to you or to other users from a particular place. Okay? It may be a distributed database management system, right, which may be residing somewhere. But from the user's point of view, it is just a centralized control that is just interacting with the system and getting back the responses. But what are the advantages of this kind of a scheme? Well, whenever we talk about the centralized control, there are many advantages or benefits associated with this scheme. And the first and the foremost being sharing of data. That is possible in existing and even new applications, may satisfy requirements of new applications without addition of any more data. What do we mean by these two? Basically, we mean by saying so that even if new applications are added, you can share data. For unforeseen reasons, you can still produce results from the existing data. And many users actually can share data of an enterprise. Doesn't it lead to security problem? Yes, but we would like to see that. The second most advantage of this scheme happens to be reduction of redundancy. One point which is mentioned over there is data administrator should see for controlled redundancy. Inconsistency can be avoided, integrity can be checked and enforced. Now, reduction of redundancy. What does this particular thing mean? Reduction of redundancy basically means that what we are basically trying to do is keep one copy of a particular item of a particular data. That's what we are trying. But that is a very dangerous proposition. If you just keep one copy of anything and by chance that copy is destroyed, how will you recover? The recovery process is basically that enforces you, or it pushes you to keep more than one copy of data, right? And if you have to keep more than one copy of data, whose job is to ensure that particular thing? Probably data administrator's job. It doesn't lie with you. So controlled redundancy are possible in a database management system. Inconsistency. Wherever there is a redundancy, there is a chance of inconsistency. More than one copies, both the copies may not be consistent. So that is to be checked once again and to be avoided. And definitely integrity constraints, that is correctness of data, has to be ensured. And this is once again because of centralized control. What else we can do with it? Well, transactions can be supported. Now what is a transaction? Is basically a unit of work. A transaction may be contained in a single program. Next is security can be enforced, conflicting requirement can be balanced, and standards can be enforced. Well, security, on one side, centralized control leads to security problem. On the other hand, it also allows us for better management of security as well as standards. Okay? Transactions. How can we deal with transactions? What is a transaction? Transaction is something like if I go to a bank, I withdraw some money. Probably something is to be done with the database management system. That's a transaction. I transfer some amount from my account to somebody else's account. That's a transaction, which is to be done completely or not at all. Okay? Conflicting requirements can be balanced. Now this is one item which will be required of you in the near future. The conflicting requirements basically boils down to that if there are two applications which want the database use in a different style, then these are conflicting requirements. Okay? And how these can be balanced? Probably by keeping indexes. Who is responsible for doing it? You. But then benefits of database approaches, you can actually do it. Okay? Last but not the least, and in fact I believe this is the most important advantage of any database management system, is data independence. In fact, this is one of the reasons why database management systems were created. Data independence and query language support. Now what does data independence mean? It is the immunity of an application to change in physical representation and access techniques. This is physical data independence. The immunity of an application programs in case of change in fields to an existing records. This is logical data independence. Well, physical data independence is basically you are changing the index structures without changing any program. This is physical data independence. But logical data independence is a step ahead. It simply says, suppose I add one more field, most of my programs should not change. And that's data independence. That is, whatever data has been stored, okay, or is in the store for you, it should not, okay, or it should be accessed through a layer of database management system. And any changes in that should not alter any application program. That's data independence. Okay. Now, what are the different types of database users? Well, the very first kind of user is application programmer, and that may be you, who will write database application programs, maybe in C++, maybe in Java or 4GLs. They may also make SQL-based requests to DBMS through programs and can create conventional batch programs or online applications. So this is the first kind of programmers. The second kind of users may be the end users. You have created a database management system or application. For whom? Probably a railway reservation system is made for you, a customer, who actually goes to an end user who gives him the interface. But there may be situations, there may be kiosks, there may be applications where user can directly interact with the database management system. That is, as an end user, and just finds out whatever query he has. What kind of questions he may be asking, or what kind of ways he will be interacting? End user interacts with DBMS from online terminal through online application or directly through the DBMS interfaces. You must have seen Access interface is one of the simplest. Interacts through command-driven interfaces or query languages, okay, by giving SQL commands. The second approach happens to be more flexible, but it requires a sort of skill, IT skill at your part, that you must know the IT, a bit of SQL as far as interaction is concerned. The third kind of user of a database management system happens to be the database administrator. And in most likelihood, you are going to be the database administrators. And what will be your responsibilities? Well, as a database administrator, you will be asked to create logical database design. You will be creating the physical database design. DBA defines security and integrity constraints. DBA defines backup and recovery policies. He monitors performance and changing environments, and he protects the data against unauthorized changes. So whatever we are going to discuss today, in fact, it is all your responsibility. You have to make sure that that does not happen, or somebody does not alter the change or frisk away with the data. You ensure that the data definitions are proper. You ensure that the indexes are proper. So many things you got to ensure with the database management system, and in fact your data. But to begin with, what we have is DBS functions and components. If I want to learn about database management system, I must know its function and components. Let's quickly go through the database components and functions. The very first function which needs to be there in any database management system happens to be data definition. And the component which need to support it has to be DDL processor or DDL precompiler. That is data definition language processor or data definition language compiler. The second function of any database management system happens to be data manipulation. For that, once again, you need data manipulation processor or compiler. And suppose you have unplanned queries, then you will be needing query language processor. You submit the query, it should be processed, and then the result should be obtained. What are the other components and functions of a database management system? Optimization and execution. Well, whatever query you have submitted should be optimized and executed. And who is the or what is the component which is responsible for it? Database runtime manager, which basically interacts with the file manager, enforces integrity and enforces security. Okay, so this is a very important component of any database management system. Are there any more components? Probably yes. What are those? Well, it goes down to data recovery and concurrency. There has to be a transaction manager, and the transaction manager has to look forward to backup and recovery policy. and as well as concurrency control. Last but not the least, metadata management. Okay, now that's a major function which most of us keep on forgetting. Data dictionary is one of the most important resource in any database management system. It should be exploited to completeness. Okay. Now with this, as far as the basic components and functions of database are concerned, what is the single and the foremost issue in any database management system? It should be the level of confidence in the data which is available over there. Okay? If you can trust that whatever data is there is 100% correct, what you are looking forward to? Integrity constraints. There may be don't confuse between the data entry errors and data integrity. Data entry errors and correction and all those kinds of things is one part of this particular correctness of data. But data integrity is from the DBMS point of view. How do you ensure that whatever data somebody is trying to enter is correct? Or, for example, if somebody instead of 5,000 has entered 500, it may or may not be caught by the database management system. But instead of 5,000, if he is just entering 0 and 0 is not allowed, probably this kind of a thing can be caught. Suppose your enrollment number, instead of 9 digits, somebody has entered 6 or 7 digits or 8 digits. That kind of error should be caught. That can be put as an integrity constraint from a database management system. And that's what we are looking forward to. What is integrity? Accuracy or correctness of data in database. Mostly RDBMS provide two kinds of integrity support. The first one is called declarative integrity support, and second one is called procedural integrity support. The declarative integrity support is the one which we normally specify when we are giving SQL commands. Whereas procedural support is something like triggers. Now let's look into the declarative support. Now declarative support comes in the form of constraint definitions. If a new constraint is declared, then the system ensures that the current state of database satisfies it. Otherwise, the new constraint is rejected. So whatever is the present data, that is current state, it should satisfy the new constraint. A system providing such support relieve application programmer of burden, thus increases productivity. In what sense? Suppose a database system does not support that the age should be less than 100, but you cannot specify a range for a particular number, and you are talking about age. If you don't have declarative support, you got to write a program to ensure that whatever age data has been entered is less than, let's say, 150. Okay? So this will in fact reduce productivity. On the other hand, you just specify it in the database management system, increases your productivity. The next important term which we would like to discuss in this particular context is foreign key concept. Why foreign key concept? Because it is all related to referential integrity. What is a foreign key? Let R2 be a relation. Then a foreign key in R2, okay, is a set of attributes of R2, say Fk, such that there exists a relation R1 and R2 not necessarily distinct, with the candidate key Ck. Okay, so in R1 there is a candidate key called Ck, and in R2 there is a foreign key called Fk. And what is the constraint? For all times each value of Fk in the current value of R2 is identical to the value of Ck in some tuples in the current value of R1. Isn't it a very heavy definition? Yes, the definition seems to be very heavy. But what is the meaning? Let's take a very simplistic figure. Suppose I keep two tables, student table and TLCs. Now what I have is TLC code table, right? So TLC codes, TLC addresses as one table, and in the student table we just need to put student number, enrollment number and so on, so student detail as well as TLC code. Now the TLC or the student table happens to be R2 and TLC table happens to be R1, where TLC code uniquely identifies a particular TLC. R is a key, CK. Okay. Now think of a situation. So in student relation, TLC code basically specifies which TLC, but that student table need to refer to TLC table. And by any chance, suppose I allocate a TLC 999 to you, which does not exist, you will be in some sort of problem. So this foreign key concept just tries to make sure that whatever is the values or whatever are the values of TLC codes which are existing in TLC table, only those values should exist as foreign keys in the student table. And this is in some sense the referential integrity constraint also. Once again look at the definition. The definition requires that every value of given foreign key appears as a value of matching candidate key. Converse is not true. So you must have a TLC code which is existing. A foreign key is simple or composite, that is not a specific requirement, and each attribute of a given foreign key must have a same name and type as the corresponding component of matching candidate key. I think I'll call it a constraint. The last one, which we have said, is a constraint onto the foreign key definition. So all database management system, we are putting these kinds of constraints. Now what is referential integrity? The referential integrity is defined as foreign key is a reference from student table to TLC table. Matching candidate key tuple is referenced. Referential constraint, what is it? A value of foreign key must match the referenced candidate key. If there is no match, there is a problem, there is a referential constraint violation. Foreign to candidate key match is the glue that holds database together. Once again, if I give TLC code 999, the glue has gone. You have no TLC. So that is the glue which is keeping all the tables together to a certain extent. What facilities does exist in SQL to support the constraints or integrity constraints in our database management system? Well, SQL facilities are provided for candidate key definition, foreign key definition, check constraint definition, and we may assign a name to a constraint. Would like to see a different example for it. Let's look into the example of a constraint. That is create table. So this is the creation. This is an SQL command. Supply part. Please note this hash sign actually is not acceptable in any SQL, but for the sake of simplicity we have included. S number, supplier number not null, that's a constraint. Similarly, part number not null, that's a constraint. Quantity not null, that's a constraint. So we are defining three fields: supplier number, part number, quantity, and all the time we are saying that they should be not null. We have not given in this particular the attribute or the type they are associated with. That you can add of your own. Next, primary key. Primary key is supplier number, part number in this particular table. That's how you specify it. That's once again we cannot call it a constraint, but it's a definition. Foreign key. Supplier number references supplier table, SUP. And what happens on delete, cascade, on update, cascade. That is, if by any chance you change supplier number of the original table to which it is referencing, if there is any change, do the similar updation here. If there is a deletion, delete all the records from here, because that supplier does not exist anymore. Similarly, it is for part number. And finally, we have another constraint, check. Quantity is greater than 0 and quantity is less than 5,000. So this is the way you can specify constraints using SQL. And you must do it. As many constraints you specify, the easier will be your life as a database administrator. Lesser will be the chances of errors. Okay, so must do that. Next is the triggered procedures. That is non-declarative support or procedural support of integrity. Well, triggered procedure basically are procedures invoked automatically on occurrence of a specific exception or a specific interval of time. Cascade referential action is a simple example of triggered procedure which is declaratively specified. In fact, in the SQL Server, which is the package you might be using, you can write triggers or triggered procedure. After the integrity, what is the next important issue for a database administrator? In fact, it is not next important. It is equally important that whatever data you store should be non-redundant, should be in the logical table organization, and tables should be correct tables. Now, what do you mean by correct tables? Well, for that a method has been proposed, and that is normalization. What is the need of the normalization? Well, normalization is basically needed to reduce, in fact to minimize redundancy, which basically implies that there should not be any inconsistencies left. Number two, no loss of information from database over the lifetime of database. What do we mean by loss of database life? I think the best thing will be to look into an example, then we can appreciate the loss of information from the database over the lifetime. We take an example of design of a student relation. Okay, so in a student relation, what can we have? Well, let's take some constraints. Just to simplify our presentation, let's take some constraints. Student names are unique, realistic, but unrealistic too. We could have used enrollment numbers, but that is perfectly okay if we can do with this. A student can join many courses, it's quite okay. Student can have one phone number only, constrained but acceptable. A student can take major in one subject. That is also there. You are mostly allowed to have major in one subject only. A course is taught by only one professor. Although this is a restriction, but we are accepting it for the simplicity of design. And one grade is given to a student for a particular course. That is also the normal norm. So except for one constraint, all other things are quite realistic. Now, what will be the defining attributes to this particular student relation? Well, the student relation automatically should consist of some bare minimum facts. That is name, course, phone numbers, major, professor, grade. Addresses and other details we are omitting for the sake of presentation only. Okay. So with this minimum details, let us try to see how the data values or attributes are dependent among themselves. Well, the first thing is, as far as constraints are concerned, let's look into the diagram for that. Name. If I know the name of the student, since it is unique and there is just one phone number, it can uniquely identify the name, can uniquely identify the phone number. That's the arrow starting from inside, goes till here. Name once again uniquely identifies the major. Once again this arrow starts from inside. Course, if course is known, I can note who has started, that is the professor. And if I know name and course, then only I can know the grade of the student. And what we are finding is name and course basically in this particular table will formulate the key to the relation. Okay. Let's look into one particular state of this particular relation. Okay. What's that? Please excuse me for this. Rohit, Matt, Rohit, Martin, Rohit and Baxter. They have taken different courses, course codes, their phone numbers. You can see the redundancy. Rohit is appearing twice, so his phone number is appearing twice. This is redundancy within table. Okay. His major, computer science, once again is repeated. CS 303, which is appearing twice because it has been taken by Matt as well as Martin, and it is taught by Bharat. At two places the same information is getting repeated. This is redundancy. What will it lead to? By any chance, if I change the phone number of, let's say, Rohit changes, what will be the result? We have to change that particular number all the way in the whole table, everywhere. By any chance we miss? Inconsistency. Now, we look into two more problems. That is, update anomalies is the one which I was talking about, inconsistency, but insertion and deletion anomaly. What do I mean by insertion and deletion anomaly? Once again, look into the table. Now, take an example of CS 379, this particular course. Okay, who is teaching it? Rod. By chance, what happened? Baxter thinks that I would like to drop this course. What information is getting lost? That the Rod teaches CS 379 or 379 will be taught by Rod. That information is getting lost. Deletion anomaly. We remove this particular tuple and we are losing information. We have lost information. Similarly, till a new course, or let's say a teacher who is supposed to teach a course, he is asked, okay, you teach CS 304. His name is, let's say, Rod. Rod is asked to teach 304. But unless a student registers for it, this particular information cannot be entered. Insertion anomaly, deletion anomaly. Let's look at the dependency diagram. How will we solve this particular problem? Well, the problem can be solved if wherever the dependencies are lying, we decompose the table with that particular thing in mind. How will I decompose this particular thing? Name, phone, major as one relation, course, professor as another relation, and name, course and grade as third relation. Try it, test it. What you will find, the redundancies has gone. The insertion and updation and all the anomalies which we were talking about are gone. What have we done? Normalized. How we normalized? Using the functional dependency diagram. What did we use? Decomposition. And what are the properties of desirable decomposition? Lossless join decomposition. That is, on taking join of the decomposed relation, have the same set of tuple as original relation. That is, if we can join those three relations again, we will get back the original relation. Try it. Dependency preservation. Constraints should not be violated. All the constraints were actually presented in the dependency diagram, and we are not violating any of those constraints. So once again, what is normalization? Normalization is an attempt to eliminate, minimize the problems occurring due to data redundancy over the lifetime of database. Is an attempt for good database design. And what technique is used? Decomposition. Okay. Now, with this, I would like to present in nutshell, how we normalize from one stage to another. That is, you know, there are multiple stages of normalization, 1NF, 2NF, multiple forms of normalization. So how we move from 1NF to 5NF. So let us quickly summarize those issues in this particular session. Now, what do? All relations to 1NF. How we do that? Eliminate variable length records and you just get a table. Over. 1NF relation to 2NF relation. What do? Remove dependency of non-key attribute on part of multi-attribute key. This is precisely what we did in the example. And we move from 1NF to 2NF. 2NF to 3NF, what do? Remove dependency of non-key attributes. Non-key attributes are the ones which are not in the yellow box as in the diagram which we have shown. So if there is a dependency among those, we got to remove those. Right. So this is the way we move from 2NF to 3NF. Now, how to move from 3NF further? Well, 3NF relation to BCNF, what do? Remove dependency of an attribute of multi-attribute key on an attribute of another overlapping multi-attribute key. In fact, this particular normal form is required whenever there is an overlapped keys, and in the overlap key there is a dependency. So for that only this BCNF, which is more stringent than 3NF, is required. BCNF relation to 4NF, basically we are looking forward to multi-valued dependencies. Remove more than one independent multi-valued dependency from relation by splitting the relation. Once again, the procedure which is being followed, split, decompose. And finally, from 4NF relation to 5NF, the basic problem is there is another relation which is to be added. Add one relation relating attributes with multi-valued dependency to the two relations with multi-valued dependencies. So we in fact add one more relation so that we can get back to the original relation without any problem. 5NF is needed when it is all key relations. Okay, so this is what we have to say about normalization. What is the next important concept? In fact, there is no sequence. I will not say that these are next important than normalization or security. They are equally important. But what is another important concept in that particular sense? Security. Security of database. What is security? Security is protecting the data against unauthorized disclosures, alterations and destructions. That's a very heavy standard definition, isn't it? That's a very heavy standard definition which we follow in any system. How do we enforce the security? Through database management system. Well, security is enforced by DBMS security subsystem, checking access request to security constraints stored in system catalog. System catalog is data dictionary, once again, check it. Giving certain privileges in a relation to certain users. So basically security is giving privileges, giving certain rights to different kinds of users. What do we do for that? Probably views are also related to security in some sense, right? That's what we would like to see. What are the views for? Automatic security for hidden data. So they are related. Shorthand capabilities are provided by views. Some data to be seen by different users in a different way at the same time. Once again, it is security related, but a logical view is being given. So it also supports logical data independence. So views is a very strong mechanism which supports security as well as data independence. So from our point of view, security is mainly being managed through the views for the time being. Later on we will see in many relational database management systems, there are ways of enforcing security. Oracle does it, SQL servers does it, you can find out from there. Example, what's the example of the view? Once again, I'm giving you this SQL definition. Create view best supplier as select supplier number, supplier status, supplier city from a table called supplier. Okay, in fact, the supplier S, the variable name can also be given, where supplier.status is greater than 15. So we have just created a view for some suppliers who have a status greater than 50. And what we are saying in addition, with check option. What does check option means? With check option means that insert and update on the view will be rejected if they violate any integrity constraint implied by the view defining expression. So you cannot update from this particular view if there is a check option available. How views are related to security? Let's look at that particular example too. That is grant, select, update. Update only on two fields we are specifying. Delete on a particular view, let's say best supply, to user 1 and user 2. So automatically you need to create these users account. And the privileges which can be given is usage, select, insert, update, delete, references. I think by name only you will be able to understand what all these things mean. Can be provided with grant option. That is, you can further whatever access rights which you have got through views, can it be further propagated? If you get a grant option, you can propagate it. When it will be needed? When a database administrator, that is you, grants certain rights to a manager. Probably you will give him grant option also, that he can propagate his access rights, probably to his or her PA. Okay? Okay. So this is in a nutshell what we have to talk about views. The next important concept is transaction, which is supported by any database management system. What is a transaction? Well, transaction is a logical unit of work. A transaction may be delimited by begin transaction and end transaction marker. Usually results on execution of program written in high-level language or data manipulation language. Anyway, we know, as I gave you the example, withdrawal or transfer of money from one account to another account is a transaction. May update various data items. Withdrawal of money probably is a single which is updating only one value, but update the transfer of some money from one account to another probably is a transaction which can update more than one data values. Now the basic thing about transaction is it is to be done completely or not at all. That is what you have to remember, and that is what you will find is available in your block also. Once again, let us look some more details about transaction. A DBMS system should ensure proper execution of transaction despite failure. Now transaction is to be done completely, not at all. if executed concurrently, no inconsistency should be allowed. If we are allowing two transactions to occur simultaneously, if they are accessing the same data, there should be ways of controlling it. That is what concurrency control is all about. Transaction commit and rollback. What do we mean by this? Commit transaction indicates everything is consistent now. A transaction is going on. Commit transaction, you have committed, over. Okay? Rollback transaction indicates unsuccessful transaction. Pull it back. Error message also need to be added with rollback. So, what basically, whenever a transaction is going on, either you will commit it or you will roll it back. There is no third possible way. Okay? And all these things are related to what? Recovery. A transaction is to be redone if it is rolled back. If it is committed, it's okay. I mean, just try to, I'll repeat it. If a transaction has been done, completed, committed, redo operation is done to ensure that recovery is, that the state which your database is in correct state. On the other hand, if you are doing the transaction, okay, and there is a failure, it is to be undone. Read it from your block. It's very interesting, but very simple also. Recovery. What is recovery? Restoring the database to a state that is known to be correct or consistent, satisfying all integrity constraints. Redo or undo. That's what you do in recovery. A failure might have resulted in inconsistent state of database. So in this particular inconsistent state of database, you will do redo operation or undo operation so that the database is brought, if you do redo, it is brought to the next state, next consistent state. If you do undo, it is brought to the previous state. What are the operations which you will do redo, which have been committed? You don't know whether the update has already been propagated to the database, that is physical database or not, or they are still lying in the memory. What are the transactions which you undo, which have not been committed as yet? Okay? Or any other rollback transaction. In any case, any rollback transaction is automatically supposed to do undo towards the end. Once again, let's look into more aspects related to recovery. Recovery is provided generally in a large multi-user shared database environment. Very little or no support for recovery is available for small single-user non-shared databases. In small database, ideal mechanism is to create periodic backup policies. In fact, backup copies, that's what we have written, and what I'm saying is policies, because policies are needed, backup policies. Copies definitely will be the result of a backup policy. How do you recover from transaction failures? That is what we call transaction recovery. A transaction is not only a unit of work but also a unit of recovery. This is very obvious for us now, whatever we have stated till right now. The only thing which we need to do, if I want to recover from transaction, I need to keep track at what stage a particular transaction is. In turn, what should I do? I keep a log of information. So what is log? Log is a sequence of log records which maintains records on all update activities. In fact, for all transactions, we keep log. What the log contains? A start transaction marker, transaction ID, who, where, record data item ID being modified, operation being performed, old values, undo portion of log, updated values, redo portion of log, and commit marker. So if commit marker is read, I know the transaction has committed. But log can also stay in the temporary storage, right? So for the recovery point of view, what should I do? Well, a write-ahead log strategy is followed for transaction recovery. What is write-ahead log strategy? The undo portion of log should be written in stable storage prior to any modification. So in case you have not raised commit marker, you can always undo. Stable storage is safe storage, that may be hard disk. Okay? And secondly, the redo portion of log should be written to the stable storage prior to commit. Right? Before I have raised the commit marker, I put the redo portion in a stable storage. So as soon as I raise the commit marker, even if I have not modified the physical database and the update is only available in the second or the primary memory, that is volatile memory, still, since the redo portion has already got recorded, I can redo that operation and get to a correct database state. Now, if a system failure occurs, what do? Probably I will end up doing system recovery. Okay, what is the system recovery? The contents of memory are lost. The uncommitted transactions are undone or restart, that is called backward recovery. The committed transactions are redone, that is called forward recovery. And that is precisely we were talking about in a very short earlier, whatever we are discussing. But what happens when more than one transactions are going on simultaneously? Probably we are running ourselves into some sort of problem, and that problem may be problem occurring because of concurrency. What is concurrency in the context of database management system? Access of database by more than one transaction public users at the same instant of time. And what does concurrency control tries to do? It tries to remove unwanted results which may occur. What can be the problem of concurrency or unwanted results? What kind of unwanted results we may acquire? Well, there are three basic types of problems which have been identified, which are lost update problem, uncommitted dependency problem, and inconsistent analysis problem. What are these problems? The lost update problem, let's look into the example. Suppose two transactions are going on simultaneously, T1 and T2. So T1 reads we are assuming a uniprocessor system only. So first T1 does some task, thereafter T2 does some task. Both are trying to modify the same data. Only then concurrency related problem will come. Otherwise, it won't happen. A is modified as 10, A plus 10, and in this particular case it is modified as multiplied by 20. So this read the value of A and let's say as 10, it made it 20, it wrote A as 20. This T2 read the value of A once again as 10, made it 200, it writes it as 200. The updated 20 value is overwritten, it's lost. The two transactions, if run independently, will not give these results. Suppose this T1 is executed first, I get 20, then 20 into 20 is 400. Right? So there is a problem, definitely a problem. So the first problem of concurrency happens to be last update problem. Okay? The second problem of concurrency happens to be in uncommitted dependency problem. What happens? That T2 writes a value A, goes on to do some other work. Meanwhile, T1 reads the new value of A, modifies it, writes it back. Unfortunately, T2 does a rollback. If T2 does the rollback, what happens? T1 has read the value of A, which was ghost value, which was never in existence, right? So what we are saying, in the uncommitted dependency, what we are saying is that T1 has read a value which was not committed, and that's why this kind of a problem can occur. Third problem is inconsistent analysis. T1 and T2, T1 is reading values A1, A2 and so on and so forth, and sometime later it is supposed to read A3, and what happens? T2 comes in between, reads the value of A3, modifies it, reduces it and adds the same value in A1. Now this is, let's assume there is a financial transfer from A3's account to A1 account. Okay? Now what? And we are finding out the total balances of all the bank accounts. What will be the result? There will be inconsistent analysis. We will come to know that the results are faulty, and this is inconsistent analysis problem. Right? So these are the three problems which can be encountered in any database management system. What are the SQL standards related? Well, SQL standards related to these identifies just three specific problems. They are dirty read, which is T1 performs some update on some row, T2 retrieves row, T1 terminates with rollback, T2 has seen a row which never existed. In fact, let's not go into the details of these three problems. What we are trying to say is all the problems, actually concurrency related problems, are identified by SQL standards, and there are various levels of isolations in which a transaction is allowed to execute, and on that particular basis there is a possibility of occurrence of concurrency related problem or not. It really depends how you tune your database application. Once again, for more details, you really have to look into the block and SQL standard. How to avoid these concurrency problems? Well, there is a very, very simple strategy called locking mechanisms, which exist in most of the database management system of today. So using locking, you can avoid concurrency related problem. But normal locking does not allow restriction of this kind of a problem. There is a scheme called two-phase locking that ensures that the concurrency related problem does not occur in any concurrent operation in a database management system. And two-phase locking is basically boils down to two basic aspects. That is, one is the locking phase and second is the unlocking phase. In the locking phase, you just acquire all the locks, and in the unlocking phase, you start releasing the locks. So this is the two phases, and they are not, they cannot be done in a mixed fashion. First, the locking phase will be performed, only thereafter unlocking can start, and this is the way of dealing with the concurrency problem. With this, I would like to sum up this particular session. In today's session, we have discussed about the benefits of database technology, the components of database technology, the problem of integrity, the problem of normalization, the recovery process, the transaction, the locking mechanism, and concurrency control, and a bit about the views and security. With this, bye for now. See you next time.